So as we go on, the minimum that the analysis has got to cover is as follows. First thing to note about that is you can't verify compliance with requirements if there are no requirements. People don't do their top-down systems engineering properly. So, if you don't ask, you don't get, basically. First of all, we've got to validate flow down of design requirements. So we need to verify that they're satisfied. Where it says test plans and procedures, that might be anything. You might have to be doing V&V by analysis, by demonstration, by testing, by other means, okay? So it's not necessarily just testing, but that's often the assumption. Moving on. So we must also identify previously unidentified hazards, because we are now down at a lower level of detail in a subsystem, and stuff probably will emerge at that level that wasn't available before. So first of all, number one, we've got to ensure the implementation of subsystem design requirements and controls, and also ensure that those requirements and controls have not introduced any new hazards, because very often accidents occur not because the system has gone wrong, the system is working as advertised, but the hazards with normal operation maybe just weren't appreciated and guarded against, or we just didn't warn the operators that something might happen that they needed to look out for. A very common shortfall, I'm afraid. And number two, we've got to determine modes of failure down to component failure and human errors, single points of failure, common mode failures, effects when failures occur in components, and from functional relationships. And again, I see very often buyers, purchasers don't think about the off-the-shelf stuff in advance or don't include it. And then sometimes also you see contractors going, well, this is off the shelf. So yeah, that's another common gotcha, I'm afraid. So we do need to think about everything, whether it's developmental or not. And then part C, recommending actions necessary to eliminate hazards if we can. Very often we can't, of course. And then we have to mitigate, we have to reduce or minimize the associated risk of those hazards in terms of the harm that might come to people. And we've got to ensure that system level hazards, it says attributed. Maybe we believe when we did the earlier analysis that the subsystem could contribute to a higher level hazard. You can imagine lots of these subsystems all feeding up a certain failure rate and different failure modes. And overall, when you pull it all together, we may have to meet some target or reduce the number of failures and their propagation upwards in order to manage hazards and risks. And of course, if we think back to the hierarchy, we prefer to fix things in the design, and we should pretty much assume that we have to do this. But in many industries, there are certain ways of doing things. And I've said before in previous lessons, if you don't specify that you want something, then contractors will very often cut the safety program to the bone in order to be the cheapest bid. But nevertheless, the contractor performing the SSHA shall monitor the software development, shall obtain data from each phase of the software development process in order to evaluate the contribution of the software to the subsystem hazard analysis. It's a GFE or NDI item, but there still should be evidence available, or you do a black box analysis of the subsystem that the software is sitting in. And again, if the software developer reports any identified hazards, they've got to be reported to the program manager in order to request appropriate direction. Now, this assumes a level of interaction between the software developers right up the chain to the program manager. So again, we can't just ignore those things. So that's slide 6 out of 6. Let's move on to reporting. A list of the subsystems and a detailed description of the subsystems being analysed, including its boundaries, and from other videos. Now, that's a lot of information there, probably text and pictures and all sorts of stuff. And that's going to need to go into a report. And again, if the PM customer doesn't specify that HAR, then they're not going to get it, and they're not going to get textual information that they need to manage the overall system. We've got to describe hazard analysis methods and techniques, provide a description of each method and the technique used, and a description of the assumptions made. And it says for each qualitative or quantitative data, yet content and format will vary. That's something else the PM has got to think about and specify up front. And then results should be captured in the hazard tracking system. We don't always have, in fact, we shouldn't have every little piece of information in the hazard tracking system, because it will quickly become unwieldy. And then the hazard log should refer out to that hazard analysis report or other reports and data, whatever they're called, so other records. So I've said repeatedly, the PM's got to think about this and ask for that. So the standard assumes that the information in A to H below is specified way up front in the request for proposal. So maybe you run a preliminary expression of interest or some kind of pre-competition exercise in order to tease out details. Well, if you don't know what the design is up front, you can't always do that, but you could say all. You may specify desired analysis methodologies and techniques. And again, that's largely domain dependent. We tend to do safety in certain ways in different worlds. In the air world, it's done in a particular way. In the maritime world, it's done a different way with road or off-road vehicles. If they're known hazards, hazardous areas, or other specific items to be examined or excluded, hopefully because they're covered adequately elsewhere, the PM or the client has got to provide technical data on all of those non-developmental items, particularly if they're specifying that the contractor will use them. Very important. And any other specific requirements. So what risk matrix, what risk definitions are we using on this program? Again, now some additional commentary. It says right up front, areas to consider include performance degradation, functional failures, timing errors, design errors or defects, and inadvertent function. Now, what we have here basically is causal analysis. So there will be some fairly simple techniques that you can use to identify this kind of stuff. Something like a functional failure analysis or a failure modes effects analysis, which is similar to an FFA, but a FMEA requires some kind of design to work on. And also FMEA, a variant of FMEA is FMECA, where we include the criticality of the failure as it possibly propagates up the hierarchy of the system, both because in many systems, the human is a key component, is a key player in the overall system. And in the past, we have tended to build systems and then just expect the human operator and maintainer to cope with the vicissitudes of that system. Its performance depends on being, lovingly looked after and tweaked, and maybe systems are vulnerable to human error and even induce human error. So we could use a number of techniques. We could use a HAZOP, a hazard analysis and operability study, to consider information flows to and from the human. There are lots of specialist human factors analyses out there, and I'm hoping to run a series of human factors sessions, interviewing a very knowledgeable colleague of mine, but more on that later. We'll look at those specialist human analysis techniques. So these have been around a long time, and they were around they were around before the year 2000. And there's quite a nice checklist on Wikipedia for things to consider we're considering all the different interfaces between those different elements. And that's at the hyperlink that you can see at the bottom of the slide. And then on the right-hand side, we've got the 5M model. And apologies for the gendered language, where the 5 M's are the man, the human, the machine, management, and the media. And the media is the environment, the operating and maintenance environment. And then in the middle is the mission. So the humans, the machines, the systems, and the management come together in order to perform a mission within a certain environment. So that's another very useful way of conceptualizing our contribution of humans and interaction between human and system, human operators, usually and maintainers, so frontline staff, let's say, and management, all in a particular operating environment and environmental context, and how they come together to accomplish the mission or the function of the system, whatever it might be. So we do tend to target this analysis in those areas and tend to spend the money, hopefully in a sensible and targeted way. So my final slide on the additional commentary, the other things we've talked about for this task: compliance checking. So we should get a subsystem specification. So if we have a subsystem spec, a bunch of functional requirements, say, very early on, we could do a functional failure analysis of those functional requirements. So we can do this work really quite early if we need to. So any mismatches there could give rise to problems. So this is a type of activity where we're looking for continuity and we're looking for coherence across the interface, and we're looking for things to join up. And if they don't join up or they're mismatched, then there's a potential problem. And also, as we look down into the subsystem, are there any derived safety requirements from above that says this subsystem needs to do this or not do that in order to manage a hazard? So those are very important to identify. Again, if it's not been done. So if going the other way, we are a higher level authority, we're a system prime contractor or something, well, we might find out some information from sales brochures or feature lists. Sorry about that, slightly fatuous example, but a very good illustration, I think. And ideally, if there's any training materials associated with the piece of kit, is there a training needs analysis that shows how the training was developed? Because very often in a TNA, if it's done well, there's lots of good information in there. Fire hazards, flammable materials, toxic materials, you name it. So there's a lot of ways that we can get information about a subsystem. Ideally, we ask for everything up front. We say, if there's any hazardous chemicals in there, then you must provide the hazard sheets and the hazard data in accordance with, international or national standards and so on. But if you can't get that or you haven't asked for it, there are other ways of doing it, but they're often time consuming and not the optimal way of doing it. And if the contractor can't supply exactly what you want or what you need, you then have to decide whether you can live with that, whether you can use some of these alternative techniques, or whether you just have to say, no thanks. But this presentation, and especially all the commentary and the added value, is copyright of the Safety Artisan 2020. And if you want more videos like this, the rest in the 882 series, and other resources on safety topics, you can find them at the website www.safetyartisan.com. So that's www.patreon.com, and search for Safety Artisan, all one word. So I look forward to seeing you again soon.